Welcome back, everybody. Welcome back to this special bonus episode of 4.8, where we combine complex numbers and the quadratic formula. Get excited. What a fun chapter this is. So, we're not necessarily learning anything new here. We're just going to combine the quadratic formula and our newly acquired knowledge of the imaginary number system. So, in this first example, I want to find all of the solutions of 2x squared minus 3x plus 5 equals 0. And here, I'm going to go with the quadratic formula to solve. Just a little bit of background of why I would use the quadratic formula. That's going to kind of be my go-to to solve for a quadratic because that is typically going to be the easiest to work with because as long as you know the formula, you can just kind of plug in your numbers and be good to go from there. So when I do the quadratic formula, I always want to write my a, b, and c values in some list to the side. Here I have 2, negative 3, and 5. I have my quadratic formula down, and I'm just going to plug in the values where I need to put them in. So I'm going to have negative of negative 3 plus or minus negative 3 squared minus 4 times 2 times 5 all over 2 times 2. Now I'm going to solve what's in the discriminant, simplify some stuff down. When I do that, I end up getting 3 plus or minus the square root of negative 31 over 4. And up at this point in Algebra 1, if you saw a question like this, even in this class, if we saw a question like this, once I see that negative number under the square root, I would stop here and say I have no real solutions. But now I've learned about complex numbers, and I can see here, okay, if I don't have any real solutions, I might have 2 imaginary solutions. And that's exactly what I'm going to get here, because remember, imaginary solutions all come from negative square roots. That's kind of where that number system stems from. So what I'm going to do here to completely simplify this and find my answers is I'm going to pull that I out of the square root and simplify from there. So with negative 31, I'm going to pull out that negative 1 and rewrite it like this. Now I can see here, square root of negative 1 turns into I. I know I'm totally simplified because what's left there, that 31 is a prime number, so that's not going to break down anymore, so that's going to be left in the square root. And to write this in proper complex number form with the real and imaginary part, my final answer here is 3/4 plus or minus I square root of 31 over 4. Those are my 2 solutions to that original problem. Let's do one more example and call it a day. Here I have x squared plus 2x plus 3 equals 0. Again, to start, I'm going to write out my a, b, and c values. Here I have a equals 1, b equals 2, and c equals 3. When I plug it into the quadratic formula, I should get something that looks like this. And then when I simplify it, I'm going to get negative 2 plus or minus the square root of negative 8 over 2. Now when I look at this, again, I'm going to pull out that negative 1, see if I can pull out anything from there. I rewrite the square root of negative 8 as negative 1 and 8 separated. But from here, I'm also going to ask myself, okay, can 8 break down anymore? And if I'm working with square roots, I want to think, are there any perfect squares that go into 8? So I could rewrite this, 4 is a perfect square, that goes into 8. I'm going to rewrite the square root of 8 as the square root of 4 times the square root of 2. Now I'm ready to totally simplify. So negative 1 is going to turn into I. The square root of 4 is going to turn into 2. I know I'm totally simplified here because the square root of 2 isn't going to break down anymore. So I'll rewrite this to make this look a little bit cleaner. Again, I'm going to write this in proper complex number form. I have negative 2 over 2 plus 2i square root of 2 over 2. I can see here that some more things simplify. So I'm going to divide 2 into both of these. And my fully simplified answer here is negative 1 plus or minus I square root of 2. Those are 2 of my complex solutions to that original problem.